This is TWiT.
Linus Torvalds has been having a temper tantrum meltdown.
Oh boy, is he pissed.
In public.
Yeah.
I mean, dropping the F-bomb and calling this a bunch of, SHIT and cannot believe what Intel is doing. And in pursuing this, I just hours ago, this morning, I found the document I had been looking for but hadn't tracked down yet, which is the ink is still wet on the PDF. It's titled It's a 15-page PDF from Intel, titled Speculative Execution Side Channel Mitigations. This is the technical details of what Intel is proposing for the microcode fixes. And because I was putting the podcast together, I had no chance to dig into it, but boy, I'm going to have fun tonight because I'm really curious, having built the inspector to bring some clarity to this and having taken the approach I took, now I'm really interested but I was always running from third-party comments. I found some ESX VMware documentation that I based some of the stuff on, and I'm so happy to get finally the original root document that is the center of this controversy. So and the problem is Linus isn't in anything I have read that he has written being clear. He's just ranting, and it'd be nice if he were to catch his breath and calm down and explain what it is that seems to be the problem. Near as I can tell, he's unhappy that Intel intends to call a solution the simple turning off of this of a couple flavors of branch prediction. That's what the whole Spectre thing is, that it's possible to leverage this speculative execution of branches and branch prediction in a way that leaks information. And so Intel's solution for now, and they've said for the time being, is to allow operating systems to turn it off. So his tantrum is that they're disabling all branch prediction with the concomitant performance hit that will bring as their solution. And he's wanting them to fix it right. Now, the reason I think he's wrong, that is the reason I don't have sympathy for his position. I mean, yes, it would be wonderful if we could have that, but microcode is not like application code. By that I mean that microcode is tightly bound to the hardware. So it's not like there's a whole processor written in software that Intel can just say, oh, well, we've decided we're going to change everything. No, it's that what the industry realized decades ago was that implementing an instruction set as complicated as Intel's in pure hardware, that is in gates, in just simple logic gates that do all the work, was becoming impossible. This is the difference with the ARM architecture, because the ARM instruction set was so simple, was so clean, they've been able to give us a high performance system that doesn't rely, I don't know if it relies at all on microcode, but if it does, not nearly to the degree that Intel's does. So essentially, Intel's instruction set got so complicated that you could no longer actually do it in hardware. You had to back off. And so what they did was they moved some of the complexity into sequential functions which are driven by this microcode. But the point is, you can't. It's, for example, their branch table prediction system doubtless is a hybrid of hardware that does most of the work and some microcode that just kind of points in different directions and says, oh, now raise this line or let this data flow through here. Okay, now stop it. Now run a compare and that kind of thing. It's not actually doing the work. It's directing the hardware, which is purpose specific to do the work. I have no doubt that Intel has learned some incredibly important lessons from this, and that downstream, that a future generation of Intel processor will solve this problem, but they can't solve it with a patch to the microcode, and that's the problem. So what Linus is asking for is not feasible. What they've done is the only thing they could do with the existing chip hardware, which is say, oh, crap. And basically, they've given us the oh, crap bit.
Yeah, they got that part set.
Yeah. And so here's the oh, crap bit. And if you turn it on, well, sorry, things are going to run slower, but that's the only thing we can do. We can let things run fast and hold your breath, or you can turn on the security bit and it's going to go slower, but this class of exploits can't happen. So Linus is not happy. But what he wants, you can't get there from here, because microcode isn't like operating system code where you could say, oh, we're going to change everything. We're on the same chip. We're going to give you Windows 98. Now we're going to give you NT and Windows 10. No, the microcode is just basically it's the minimal required to simplify the hardware, but you're stuck with the hardware that you've got, which is doing all of the real work. Microcode is just like a traffic cop, raising and lowering, allowing data to kind of flow where it's supposed to, and simplifying the process.